Welcome back. Previously, we were discussing about the theoretical aspects of various measures of central tendency, and we have discussed in detail the concept of geometric mean. Let us discuss the next tool that comes under the measures of central tendency, harmonic mean. Harmonic mean. Harmonic mean of a set of n values is defined as a reciprocal of the mean of the reciprocals of those values. Harmonic mean is mainly used when it is desired to give the greatest weight to the smallest item. It is applied in averaging ratios, time, etc. The concept regarding the explanation now may not be understandable, and the thing is that in geometric mean we learned that geometric mean give importance to smallest item, whereas harmonic mean will give importance to smaller items that are neglected in geometry. That is the concept of using harmonic mean. The point where geometric mean cannot be used is dealt by using harmonic mean. So harmonic mean is almost like a geometric mean as a measure of central tendency in solving special type of problems. As I just mentioned now, it is used for dealing with smaller items, giving importance to smaller items. Harmonic mean is the reciprocal of the arithmetic average of the reciprocal of the values of various items in the variable. We will come to that part because it is regarding the computation details. So let us go to the computation part. Unlike the methods which we have discussed earlier, it also has three different cases: individual series, frequency distribution case or a discrete series situation, as well as continuous series. So the equation for finding harmonic mean is n divided, in case of an individual series, equation is n divided by sigma 1 by x. X will be given, you need to take the fraction of each individual item of x, then you need to take the total and substitute the same in the equation. In case of a discrete series, we know what will come to the equation part. A new item will come, that is f. So the equation is hm equal to n capital N. Remember, in case of a frequency distributed details, n means total of f. Equation is sigma, same equation, the only difference is that there is a f in between sigma and 1 by x. And regarding continuous series, it is very easy to find. Equation will be the same, the only difference is the computation part, because in the continuous series you need to create a new column, that is mid x, and we all know how to find the mid x of a certain details. So it's very easy to find the value of harmonic mean, and I hope you know what is the concept of why we are using harmonic mean. It is for, as in the theory which we have discussed previously, it is for dealing with special type of problems. And what is the difference regarding harmonic mean from other means is that harmonic mean give importance to smaller values. So the next is a knot. Remember, we have discussed a similar type of a knot in the previous slide. Geometric mean is equal to root of arithmetic mean into harmonic mean, and at the same time geometry mean square is equal to arithmetic mean into harmonic mean. Remember these two equations plus the equation which we have learned in the last slide, because sometimes you may given a case where geometric mean, harmonic mean and arithmetic mean will be directly given. Sometimes you may need to find any one of the items using these equations. So remember to use these two equations accordingly. So next, let us go to the merits and demerits of harmonic mean. Harmonic mean possesses most of the important properties of a good average. It is based on all the observations. It is amendable to more algebraic treatment. It is not affected much by sampling fluctuations. It is rigidly defined. It can be used to average relative values. Harmonic mean possesses some of the benefits or the merits of arithmetic mean, and one or two points of the median as well as mode. So just go through the merits point. It's very easy. Just go through it. We are not going further into the cases because the concept is almost similar for the each individual points. Demerits is it is difficult to calculate and not easy to understand. For us, it will be easy and not an issue. For a common man, it will be very difficult. Unlike an arithmetic average or arithmetic mean method, harmonic mean is difficult to compute. It gives greater weight to larger items. Sometimes, even though it give importance to smaller items, it might go for giving importance to larger items. In that case, the concept is not acceptable. It cannot be computed when there are both negative as well as positive items. Because unlike mean, median and mode, other methods like geometric mean, harmonic mean are affected by, much largely affected by negative as well as positive values as well as zero. So harmonic mean is not a popular average because it poses some of the main issues that should not be present in an average. So these are the concepts that comes under the harmonic mean situation. Harmonic mean is useful for averaging rate regarding rate of increase in profit, rate of increase in speed and rate of increase in price. These are the areas in which harmonic mean is used and useful. So these are the concepts, theoretical aspects and concepts that comes under harmonic mean. So we have almost completed the various tools that comes under measures of central tendency. So let us deal with some of the cases that comes under harmonic mean. A question is given, x is given, you need to find harmonic mean. So it's very easy. X is given, you write down the x values of x, and next column you need to find 1 by x, because in the question it is given that sigma 1 n divided by sigma 1 by x. So you need to find 1 by x, 1 divided by each individual item of x, and you need to take the total of this column, then substitute the same in the equation, sm equal to n divided by sigma 1 by x. You will get the answer 3.125. It's very easy for us. It is very easy for a common man. It is very difficult, as we have mentioned in the case of a demerit. This is a method for finding the value. Next one, harmonic mean from the following data. Size is given, f is given, very easy. Just substitute the details in the equation. X, write down the x, write down f. Next one, 1 by x. I hope you know how to find 1 by x. Write down each item of 1 by x. Next one, f into 1 by x. Remember, previously you have taken the total of 1 by x, but in case of a discrete and continuous series, you need not have to take the total of 1 by x. You need to take the total of f into 1 by x. Here it is 10.032. By substituting the same in the equation, n divided by sigma f into 1 by x, n is the total of f. You need to take the total of f. You will get 100 divided by sigma f into 1 by x. The answer is 9.97. Next one, find the harmonic mean from the following data. A class is given with its frequencies. Just substitute the details in the equation. Same method, concept. The only thing is that you need to find the mid x. See, here the class was given. For the time being, I am just directly going for the mid values. So the mid value of 10 to 20 is 15. That's why here x is written. You may think that details regarding x is not given in the question, then how come this amount or this details is given in the answer? The concept is I have directly gone for the mid value. So you need to find the mid value of each individual class. I have likewise I have written here. F is also written. You need to find 1 by x, and finally f into 1 by x. The next all the methods are almost similar. The only thing is you need to find mid x. Only on the basis of mid x only you can find 1 by x and subsequent steps. So substitute the details in the equation. Harmonic mean is the same equation, n divided by sigma f into 1 by x. N is total of frequency 30 divided by total of f into 1 by x, 1.006. The answer is 29.8. So this is how you need to find the values or the cases regarding harmonic mean. Next one, measures of dispersion. So next one, measures of dispersion, otherwise known as measures of variability. So what is meant by dispersion or variability? And what is the difference between measures of central tendency and measures of dispersion? Previously we learned the measures of central tendency, averages like mean, median, mode. And on the basis of these three methods, we have reduced the details given in the question, like x may be given, f may be given, and finally you will come to an end where you will get the answer for the entire details within a single figure. And we have done numerous cases regarding that. These measures, which we have discussed earlier, measures of central tendency, indicate the central tendency of a frequency distribution in the form of an average. An average is a single significant value which is used to describe a distribution. Because an average marks of a certain class is given, you will get a value. That means the average marks of that particular class or the entire details. These averages tell something about the general level of magnitude of the distribution, because it will give a general information regarding the details, but the same averages fails to show anything further about the distribution. Anything further about the distribution means the averages which we have learned, like mean, median, mode, geometric mean and harmonic mean, doesn't mention about the variability or the dispersion between the numbers within the values. I will go to the simplest form of the explanation. For example, average marks of a class, the marks of 10 students will be given, and by using the appropriate method you will get the average mark of the class. But that average method or the method which you have used doesn't mention the variations between the marks within the class. That is one of the issue with the measures of central tendency. It doesn't give information regarding the variability or the difference between the values within the x. You may given 10 items in x, and for finding the average within that 10 items it is very easy, but without that we need to identify the difference between or the variation between each individual item. That is an important part regarding various issues, because we have to use the methods of statistics in the case of a business, and we need that information regarding the variations or dispersion regarding each items within the series. So in order to find or in order to solve that issue, we are using measures of dispersion. So dispersion refers to the variability in the size of items. As I have mentioned earlier, it speaks about the spread or scatter of the values in a series, because the difference between the values within the x, you will be given the values of x like 10, 20, 50, 30 likewise, and you will get that, you know how to find the average of that series, but it doesn't mention about the difference between each individual series. That problem is solved in the case of measures of dispersion. So it studies the extent to which the values of a series differ between each other. It is very important while dealing with business aspects. So basically there are two measures for measuring the dispersion. One is absolute measure and another is relative measure. So what is the meaning of absolute and relative? Absolute measure of dispersion are expressed in same units in which data are collected. It means the data may be collected in the form of marks of a student, age of a student, likewise. So the same detail or the same unit or a scale may be used for expressing the same. Expressing the same means expressing the difference. So they measure variability in a series. Next, where is absolute measure? There are different methods or tools for measuring dispersion. And regarding measuring the absolute measure, there are different tools such as range, quartile deviation, mean deviation and standard deviation. These are the four most important tools that comes under measures of dispersion. And this is the first part. Next one, relative measure. Relative measure of dispersion is the ratio of measure of dispersion to an appropriate average from which deviations are measured. It is also called coefficient of dispersion. They measure variability by comparing two series. That is, in relative measure, it studies the variability between two different groups. Two different groups means if you are given the details, means height details of two set of students. In such situation, the variation between each individual items between these two groups can be analyzed using a relative measure. So what is the difference between absolute and relative measure? Absolute measure can be study the variability on a given set of details regarding one set of group, whereas relative measure helps in comparing at the same time checking the variability between two different groups. That is the concept of absolute measure and relative measure. And the relative measure of dispersion are useful for comparing two series for their variability. Greater the value of the relative measure of the dispersion in a series means greater in the variability in that series. Higher the value means higher variations. Lower value means lower variation between the values within the series. And some of the measures for measuring variability, various relative measures are, it's very easy, the same term, range, quartile deviation, mean deviation, and for standard deviation the name is different. In the front of each value you need to use coefficient of range, coefficient of quartile deviation, coefficient of mean deviation, and finally for standard deviation the name is different, coefficient of variation. Because standard deviation is mainly used to study the variability between groups as well as individual details. So it is known as coefficient of variation. So these are the basic theoretical aspects regarding measures of dispersion. So let us go to the next part. First one, range. Range is the simplest possible measure of dispersion. It is the difference between highest and lowest values in a series. So range is the simplest measure of dispersion. It is a rough measure of dispersion. It depends upon the extreme items and not on the base of all items of the series, because the equation for finding the range in case of individual series as well as discrete and continuous series is in absolute measure. We will be using the equation h minus L. H means highest value in the case or in the question, minus L means lowest value given in the case. That is the equation for finding the absolute measure in case of a range. See, it is the easiest equation in this subject. So, next one, relative measure, the equation is quite different. The only thing is that the range is highest minus lowest divided by highest plus lowest. So why there is a difference regarding absolute? There will always be a difference between absolute and relative measure. The thing is, range is calculated on the basis of highest and lowest values in almost all purposes. But in case of comparing two different units or the two distribution with different units, like if you are given a question where one set of details is regarding the height of students and another set of details regarding weight of students, in that case the two different items are coming to different scales, units or scales. One is on the basis of height, another is weight on weight. So the range of the weight of the students cannot be compared with the range of the height of the students, as the range of height and weight would be in different appropriate scales. We use the equation h minus L minus h plus L. So you are using the relative measure whenever you are unable to find or unable to compare two different units of a kilo. So it's very easy to find. The equation is h minus L for measuring the absolute measure, and for measuring the relative measure it is h minus L divided by h plus L. So find the range and coefficient range for the following data. Very easy. This is an individual case. So it is very easy. Try to find the highest value and the lowest value. Substitute the same in the equation h minus L and coefficient of range h minus h plus L, because in the question you are asked to find the range and coefficient of range. So h minus L, highest value and the lowest value. So just substitute the same. 85 minus 10 equal to 75, and 85 minus 10 divided by 85 plus 10, because h minus L divided by h plus L, you will get the answer 79. So it's very easy. Next one, discrete series, because here x and f is given. Same case, don't worry anything about it, just go through the x, because h and L means highest and lowest value in the x. So the highest value is 25 and lowest value is 10. So just take the difference, you will get the answer. So don't confuse with the f and x. You may think that you have to go for the highest value in f. No, that doesn't like that. You just go through the values of x, just like an individual series. And regarding this one, continuous series. See, in this question the series is not in a continuous form, because see, 20 to 29 and after 29 it is 30 to 39. So here there is no continuation regarding these two classes. So whenever you come across a question like this, you need to make necessary changes in the classes so that there must be a continuation between each individual class. And I hope you know how to bring a continuation in each individual class. You need to deduct 0.5 from the first value, and you need to add 0.5 to the second value. So here the new class will be 20 minus 0.5, it will be 19.5 to 29.5. And similar case here it is 30 and 39. You need to deduct 0.5 from 30, and you need to add 0.5 to 39. So 30 minus 0.5 means 29.5. See, you will get 29.5 here in this end, and here you will get 29.5 in this end also. So now it is continuous, and I hope you know how to find how to make necessary changes to bring continuation in the series. So here the highest value will be 69.5, because here n value is 69, so 69 plus 0.5, 69.5, and the lowest value is 20. 20 means 20 minus 0.5, it is 19.5. So substitute the same in the equation, you will get the answer 50 and 0.56. I hope you understand the concept. So next one, next method for measuring the dispersion is quartile deviation, otherwise known as semi-interquartile range. So what is the concept regarding interquartile range and the quartile deviation? If you are given a number of items regarding marks or age of students of a class in the form of an x means details of 10 students is given likewise, and how the quartile deviation works. By eliminating the lowest 25% and eliminating the highest 25% of items in a series, we are left with the central part, that is 50%, which are ordinarily free of extreme values. So by classifying the entire details into different quarters, and on the basis of those differentiated quarters we are doing the computation part. That's why the term quartile deviation is used. quartile deviation is defined as a half of the distance between the third and the first quartile. We all know what is meant by quartile means, because if we divide the entire series into 4 parts, you will get 4 quarters. And in quartile deviation, why we are doing like that is, if you divide the entire series or details regarding x into different quarters, you can remove an issue regarding extreme values, because usually we come across a term that extreme values affect each methods. So if you follow this quartile deviation, you can remove extreme values, and usually extreme values come to the first set and at the end set. So if you remove the first quarter and the last quarter, you will get a middle set of numbers, and on the basis of the middle set of numbers you will do the computation. That is the concept of quartile deviation. And the equation for measuring the quartile deviation, it includes two methods: absolute measures as well as relative measure. The absolute measure equation is q3 minus q1 divided by 2, and relative measure is q3 minus q1 divided by q3 plus q1. And what is meant by q3 and q1? q1 means first quartile and q3 means third quartile. And there is an equation for finding first quartile and third quartile. Let's go through let's discuss about the equation. In case of an individual series, just like the methods which we had discussed earlier, so the equation for finding q1 and q3, the equation is q3 is n plus 1 by 4. Since it is an individual series, here n is small n plus 1 by 4 into 3. And for finding q1 is n plus 1 by 4 into 1. There is the computation like that, n plus 1 divided by 4 into 1. Since into 1 doesn't affect our computation, that part is neglected. So in some text or in some syllabuses, you may find here n plus 1 by 4 into 1. It doesn't affect our computation. So q3 and q1 equations are like this. In case of an individual series, arraying is necessary. I hope you know what is the meaning of the term arraying. Arraying means arranging in ascending or descending order. In case of a quartile deviation, you need to arrange the given series in ascending or descending order. As I have mentioned earlier, in quartile deviation, we will be neglecting the first part and the last part of a series. Since it is arranged in an ascending or descending order, the first part values and the last part values will be neglected. That is the concept of quartile. Means quartiles is we divide the entire series into different quartiles. First and the last quartiles are neglected. So the extreme values will be neglected because they are arranged in an ascending order or an descending order. Likewise. Remember, only it is applicable only in the case of individual series. So let us go through the next one. Next one, interquartile range. Interquartile range is computed by deducting the value of the first quartile from the value of the third quartile, q3 minus q1. So it is very easy. So next one, compute quartile deviation, interquartile deviation, and coefficient of quartile deviation. And remember, sometimes instead of quartile deviation, term quartile deviation, the equation for finding quartile deviation is q3 minus q1 divided by 2. So just go through the equation. See, here interquartile range is q3 minus q1. So if you divide this computation by 2, you will get quartile deviation. So another term of quartile deviation can be written as semi-interquartile range, because we are dividing the same equation by 2. So you will get semi-interquartile deviation. Remember that term also. Okay, let us try some of the cases that comes under quartile deviation. Compute quartile deviation, interquartile deviation, and coefficient of quartile deviation from the following data. It is a case of an individual series. As I have mentioned earlier, in case of an individual series, you need to arrange it in ascending or descending order. So after the arrangement, it will be like this. Next, you need to find q1 and as well as q3. Q3 size of n plus 1 by 2. N means number of items. Here there are 11 items, so 11 plus 1 by 2 into 3, you will get 9. 9 means 9th item. So out of the series 8, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9th item is 29. This is how you need to find the value of Q3. Similarly, Q1 is size of n plus 1 by 4 and 11 plus 1 by 4, you will get 3. 3 means third value. 1, 2, 3. Third value is 10. So now you have Q3 and Q1. Just substitute these two values in the corresponding equation. Quartile deviation is Q3 minus Q1 by 2. Q3 is 29. 29 minus 10 by 2, you will get 9.5. Next one, interquartile deviation is Q3 minus Q1, that is 29 minus 10, 19. And finally, coefficient of quartile deviation is Q3 minus Q1 divided by Q3 plus Q1, that is 19 divided by 39, you will get 0.49. So this is how you need to find or deal with quartile deviation situation, mainly individual series. Next case, discrete series. The equation, there is a slight change in the equation even though the concept is same. Q3 is n plus 1 by 4 into 3, but here the n is capital N. N capital N means total of frequency. Q1 is n plus 1 by 4 and n is total of frequency. And we know what is when n. N means total of frequency, sigma f. Find quartile deviation, and the equation for finding quartile deviation is almost similar. The only difference is in the computation regarding Q3 and Q1. X is given, F is given, so it can be written in the table like this. So remember, in quartile deviation, in case of a discrete series, X is given, F is given, and you need to find cumulative frequency. And I hope you know how to find cumulative frequency. You need to find the cumulative frequency and note it in the table. Once you find the cumulative frequency, you have to use the equation Q3 and Q1. Q3 is n plus 1 by 4 into 3. N means capital N. Capital N means total of frequency 69. Here the total 69. Here the last value in the cumulative frequency column is 69. If these two numbers are same, your computation was correct. 69 plus 1 divided by 4 into 3, you will get 52.5. Since it is a case of a cumulative frequency computation, you need to go for the value within which the 52.5 comes. 3 is smaller than this one, so it will not come. 28 will not come. 48 just a bit small. 56, yes. 52.5 comes under cumulative frequency of 56. So the value of Q3 is 19. This is how you need to find the Q3 value in case of a discrete series. Similarly, you need to equation for the Q1. Q1 is size of 69 plus 1 divided by 4, you will get 17.5. Again, you need to go for the CF column. 3, 13, yes, 17.5 comes under 28. So the value in 28 comes is 10. So the value of Q1 is 10. So now we have Q3 and Q1. So just substitute these two values in the equation which we have learned previously. Quartile deviation is Q3 minus Q1 divided by 2. You will get 4.5. And next one, continuous series. In some situations, some question you may ask to find only quartile deviation. So just go through the question. Sometimes they may specify to find quartile deviation or semi-quartile deviation or interquartile deviation or the coefficient of quartile deviation. So just go through it. Next one, continuous series. As we all know, in this equation there is a slight change. See, here it will be n by 4 instead of n plus 1, and Q1 is n by 4. So if you go through all these computation, you can see that it is almost similar to the method which we have learned in case of a median. So these two formulas give the class in which the quartile lies. The specified values of the quartiles are obtained by interpolation in formula. Once you find the value of Q3 and Q1, you need to use this equation for exactly identify which value that comes under that particular class, because by using this equation you will exactly pinpoint or identify in which class the x belongs. But the class doesn't give much information. You need to identify the or pinpoint the value that comes within the class. So the equation for finding that pinpoint value for q3 is this one: L1 plus 3 into n divided by 4 minus Cf divided by f into C. If you go to the equation, it is almost similar to the equation which we have learned earlier. L means lowest value in Sn. 3n by 4 is almost similar to this equation. Minus Cf means cumulative frequency. Remember, this Cf represents a number preceding that particular Cf. If you have gone through the previous equations like this, you will understand the concept. Frequency is comes under that particular line, and C is the class interval. And similarly, in case of a Q1, there is a slight difference. Just go through the equations. So let us try one case. L1 is the lower limit, F is the frequency, Cf is the cumulative frequency preceding. Remember, preceding cumulative frequency. And C is the quartile class interval. So let us try one case. C. Next case, obtain the quartile deviation of dispersion and its coefficient from the following. So it's a case of a continuous series, and it is also in continuous series. See, it begins with 0 to 10, after that 10 to 20. So it is in continuous form. Frequency is also given, so you need to find the quartile deviations as well as coefficient. So before you go into quartile deviation, you need to find Q3 as well as Q1. So before we go into that, just write down the details given in the question in a table. So it will be like this: size, frequency and cumulative frequency. See here, the last number and the total is almost same. So your cumulative frequency computation will be right. Next, you need to find Q3. Q3 means n by 4, n means 623 divided by 4. You will get 155.75. Remember, this is not the value. You have to go through the cumulative frequency and make sure which one comes the point where 155.75 can be included. So if you see that 173 is a number that covers 155.75. So 173 is in the class of 30 to 40. So now we have class for the Q1, that is 30 to 40. Now you have to use the equation for finding the exact value of Q1 using the interpolation equation. See, the equation is L1 plus n by 4 minus Cf divided by f into C. L1 is, see, the lowest number in this class is 30. 30 plus n means total of f, 623 divided by 4, n by 4. Here it is already computed 155.75. So we can directly substitute the same value, 75 minus Cf. Remember, you might think that this Cf has to be taken. No, you have to take the preceding value, that is 98, because here the value, here the subtraction, the result should not have come as a negative value. So if you take 173, you will get a negative value. Remember, if you take 173, you will get a negative value. So you need to take the preceding value. So 155.75 minus 98 divided by f. F is the frequency that comes under that particular class. Here the class was 30 to 40, so the frequency is 75 into 10. 10 means the difference between these class interval. 30 minus 40 is 10. So you will get 37.71. So the Q1 of this particular question is 37.7. Likewise, you need to find Q3. So equation for finding Q3 is size of n by 4 into 3. N is 623. 623 divided by 4 into 3, you will get 467.5. Go through the CF where 467.5 can be included. See, here it is 498. So the class is 60 to 70. So now we have the class of the Q3, that is 60 to 70. Now use the same equation of Q3, that is Q3 equal to n1 plus 3n divided by 4 minus Cf divided by f into C. See the difference between Q1 and Q3. See, here it is n by 4, but in case of Q3 it is 3n by 4. So let us substitute the values. L1 is 60 plus 3n by 4. We already computed here. See, 467.5. Substitute the same value minus 383. Remember, 60 to 70. Here CF is 498. You need to take the preceding value 383 minus 383 1 by 115 into 10. You will get 67.33. So now we have Q1 as well as Q3. Now just substitute these values in the equation. Q quartile deviation is Q3 minus Q1 by 2 equal to 67.33 minus 37.7 divided by 2. You will get 14.815. And in the question it is asked to find coefficient. So coefficient of quartile deviation is Q3 minus Q1 divided by Q3 plus Q1 equal to 67.33 minus 37.7 divided by 67.33 plus 37.7 equal to 29.63 divided by 105.43. All these are basic maths. That's why I'm going in a pace. You will get 0.28. So this is how you have to deal with a quartile deviation situation when the sequence or series is given in continuous pattern. It's very easy to find. Remember the equations you have to follow. Just go through it. So let us go to the next area, mean deviation. This is another important tool that comes under measures of dispersion, where mean deviation is used to find how far is the difference or the distance between the normal value from its extreme values. Because we need to have an idea about the details which we are studying in detail. So mean deviation helps in identifying how far from the normal. That is the concept of mean deviation. How far from the average. That is the concept of mean deviation. So mean deviation is defined as the arithmetic mean of deviations of all the values in a series from their average, counting all such deviations as positive. Remember the sign positive. The average selected may be mean, median or mode. Remember, for mean deviation you might be using mean, median or mode, any of the three methods to identify the variations. And the equation for finding the mean deviation is sigma d by n. Sigma d, here the sigma signless d means total of d. D means deviation. I hope you know how to take deviation. Deviation means x minus average. See, deviation is x minus. X is the number that is given in the question. It may be age of the students, mark of the students, likewise. And minus average. Average means, as I have mentioned earlier, you can find the value of mean deviation using mean, median as well as mode. So x minus average means if you are using mean, you need to take the deviations from the mean value. If you are using the median method, you need to take the deviation from x minus that median value. Similarly, the same case for mode. So represents the deviation from an average without sign. Without sign means we will be neglecting the sign of that particular computation. N being the number of items. N means number of items. We all know what is the meaning of small n. Mean deviation is an absolute measure, whereas coefficient of mean deviation is equal to, or the method of finding the coefficient of mean deviation, and in simple terms means relative measure of mean deviation is mean deviation divided by mean, median or mode. As I have mentioned earlier, the average, in order to find the average, you might use mean, median or mode. If you have used mean for finding out these values, that is mean deviation as well as deviation from the various value. If it is mean, then you have to use the equation mean deviation by mean. If you have used median in this case, you have to use the equation mean deviation divided by median. If you have used mode, then it will be mean deviation divided by mode. Any of the three methods. I hope you are following it. Let us deal with the computation part. in case of an individual series. So remember, in the mean deviation, the thing is that you need to have an idea about how to find the average using mean, median, mode, and at the same time you have to have an idea about how to find mean in case of individual series, discrete series, continuous series, likewise for median and for mode. So you should have a detailed idea about computation of mean, median, mode, and its all three cases. Then only you can compute the value of mean deviation. That is the main aspect of mean deviation. So in case of individual series means you need to have an idea about how to find mean, median, and mode in case of an individual series. And remember, you need not have to use mean, median, and mode in the same question. Any one method is followed. Sometimes the average may be specified in the question, because in the question it will be given as compute mean deviation using mean. If some average is specified in the question, you have to follow that particular average. If nothing is specified in the question, you can use any method, whether it is mean, median, or mode, up to your discretion. Okay, first one, individual series. Calculate mean deviation from median and its coefficient from the following. See, in the question it is already given median. In that case, you need to use median method. You need not have to worry about mean or mode. So regarding individual series of a median, x is given, so no details regarding f. So in case of a median in individual series, remember the rule, you need to rearrange the details. So after rearranging, we can write it in a table like, see, 5, 25, 28, 33. Here I have arranged the same in the ascending order. Next one, in the equation it is given sigma signless d. D means deviation. Deviation can be computed by x minus average. In this situation we have been using median. So the computation of median, I hope you know how to find median in case of an individual series. See, the equation for finding, before we go into this part, we will find how to find this 44. Mean deviation equation is sigma d by n, where d is x minus median and median is n plus 1 divided by 2. Here number of items is 11. 11 plus 1 divided by 2 is 6. 6 means sixth item. 1, 2, 3, 4, 5, 6. So the sixth item is, sorry, not this one, here 1, 2, 3, 4, 5, 6. Sixth item is 44. So now if you have median, so you can now find the value of d, that is x minus average. Average in this situation is median, so it is 44. So you need to take the difference between each individual value of x with median, that is 5 minus 44, 39. Remember, here it is given signless d. If you put two lines in between in both sides of the variable, it means signless. Signless means you need not have to worry about plus or minus sign. It doesn't affect our computation. See, 5 minus 44, it has to be minus 39. Since it is signless d, you have to write it as 39. Likewise, you need to take the difference between of each individual value of x with the 44. Then you will get a set of numbers and you need to take the total of this signless d, because the equation is sigma signless d divided by n. So the equation is like this. So mean deviation is 321 divided by n is 11, so you will get 29.18. And in the question it is also asked to find coefficient of mean deviation. So coefficient of mean deviation is mean deviation divided by median, because the equation is mean deviation divided by any of the average. In this question we were using median, so you have to use the equation mean deviation by median. Mean deviation we already found 29.18 divided by 44, you will get 0.66. This is how you need to find the mean deviation as well as coefficient of mean deviation in case of an individual series. Another question, find mean deviation from the mean and its coefficient. it's just an activity. Try to find. It's a very simple method. Individual case, individual series situation where you have to use the mean average. So try to find the mean deviation and coefficient of mean deviation of this question. We will continue to the next part. Discrete series. As I have mentioned earlier, discrete series, there will be another column, that is the frequency column. And the thing is, you need to have an idea about how to find the mean, median and mode in case of a discrete series. That is the aspect regarding computation of mean deviation. The equation is, mean deviation is sigma f sin less d by n. There will be a f column, so you need to multiply f column with the sin less d column. And here n is capital N means total of frequency. So let us try an example. Compute mean deviation about mean and coefficient of following data. X is given, f is also given. So let us substitute the two details in a table. So before that, here mean, you need to find the mean, because in this question there it is specified that you need to find the mean deviation using mean. So the equation for finding the mean in case of a discrete series is sigma fx divided by n. And the table is like this. Here x is given in the question, f is also given. Since the computation of mean in case of discrete series is known to everyone, first of all you need to find fx. Fx means f into x. So if you multiply these two columns, you will get fx. And take the total of frequency as well as fx. And next you have to do is find the mean. So you have found that the mean value is 1.02. Next you need to take dx. d or dx, mean deviation about mean is sigma f sin less d divided by n. And for computing that, we have f and we don't have sin less d, so you need to find sin less d. After that you need to multiply f with sin less d. So let us find sin less d. Sin less d is x minus 1.02. Here x is these values and minus average. Here we have used this mean value is 1.02. So if you take each difference of each individual value of x with 1.02, you will get this column, and you need to find next column, that is f into sin less d, because in the equation it is sigma f sin less d. So f into sin less d means you have to multiply each number of f with the sin less d, you will get f sin less d. And you need to take the total, because in the question it is said that sigma f sin less d by n. You need to take the total of f sin less d. So the equation is 351.12 divided by 350, you get 1. So now we have mean deviation 1. Next is coefficient of mean deviation. Equation is mean deviation divided by mean. Since we have used the method mean, we are using the same value here also. So mean deviation is 1 divided by 1.02, you will get 0.98. So this is how you have to deal with mean deviation situation in case of a discrete series. So if you go through it, you can see that if you have an idea about mean, median and mode, you can easily find the value of mean deviation, because the entire computation is based on mean, median and mode. The only difference is you need to take the you need to take the product of f and sin less d. So it is very easy. And for an activity, I am giving two cases. See, it is a case of continuous series. I am not going further into continuous series, because we all know how to find continuous series. Means if it is a continuous series, in the first question find the mean deviation about arithmetic mean, and we all know how to find the mean in case of a continuous series. You need to use the mean method for finding the value of mean in this continuous series. And on the base, so once you found the mean value, you can easily find mean deviation. Likewise, calculate mean deviation from median for the following data. Here it's a continuous series, and you know how to find the value of median in case of a continuous series. So try to find the answer, whether you are getting these answers. So just try to find yourself, just go through it. If you have any queries, please let me know. We will discuss about the next part in the next session. That's all. Thank you.